Vsauce. I'm Jake, and it is good to have some company out here. I've been alone for quite some time. Now, we are currently headed 10,000 light years away from Earth. You actually just passed Alpha Centauri on your way in here. It's our closest star system to our own solar system at 4.3 light years away. We're about 25.7 trillion miles. Now, this would have taken a very long time with older technology, but here in the future, well, we can travel at 99.99% the speed of light. That is much faster than what you're probably used to. The fastest speed a manned spacecraft achieved in your time was Apollo 10 at 24,790 miles per hour. That would have taken over 100,000 years to get to Alpha Centauri. So scientists tried to create ships that were even faster. Project Orion is the most well-known. It used nuclear pulse propulsion, atomic bombs being detonated at intervals behind the ship to propel itself forward. Orion, even though it was incredibly forward-thinking and would have pushed us closer than ever to interplanetary travel, never came to fruition in part because of the Nuclear Test Ban Treaty in 1963. Theoretically, a fusion-powered Orion could achieve velocities up to 10% the speed of light, meaning it would only take 44 years to make the journey to Alpha Centauri. Of course, all this assumes that you don't want to slow down at the other end. Carrying enough fuel to slow down doubles the travel time. One of the difficult let me clear this, there we go. One of the difficult aspects of long-distance space travel is acceleration. It isn't instant, it can't be for manned missions. When we start talking about 10, 25, 50% the speed of light, accelerating there is a slow process. Getting to just 1% would take 36 days. If you hit the thrusters and immediately accelerated to that speed, you'd be instantaneously killed due to the immense G-force. And then what remained of your body would make the cockpit look like abstract art. There are a lot of things to factor when it comes to interstellar travel. For one, space isn't empty. There are dust clouds, space debris. When you are going at these immense speeds, at say half the speed of light, just hitting a piece of debris the size of a quarter would be equivalent to being hit by a 15 kiloton atomic bomb. Energy is another. The amount of energy needed to accelerate a metric ton spacecraft, like this one at even half the speed of light, would require 2 months worth of the entirety of Earth's energy output, and another 2 months worth to slow down. Quick side note, our craft is incredibly light. A NASA space shuttle weighs about 2,000 times more and would require 2,000 times the amount of energy. At the speed we are currently traveling, 99.99%, it requires in total 20 years worth of Earth's energy output. But the one I find the most debilitating, the one I'm currently experiencing, is loneliness. Space feels limitless, but there are limits. Communications can only travel as fast as the speed of light. There is no way currently known for that to be any different. So you find yourself alone. In movies, they always showed home base communicating immediately with the ship. But the fact of the matter is, the further out you go, the longer it takes. So by the time you receive that message, the people that sent it are most likely not going to be around to hear your response. On an interstellar mission, it isn't so much who you talk to, but how many. Speaking of messages, if you were wondering why I'm traveling 10,000 light years away, it's because we received a message from an alien civilization at that distance. So good, luckily we can hop in our 99.99% speed of light ship and get there in 14 years. One way. However, time isn't a straight line. Time is relative and doesn't move at a constant rate. The faster you move through space, the slower you move through time, relative to anything not going that speed. For example, at our current speed, what is a 28-year round-trip mission for me is 20,000 years for everyone on planet Earth. And this leads us all to a specific limitation, a specific boundary of what is possible, a limit to what we can do. Here, I actually got a message from another interstellar traveler named Matt O'Dowd from the ship PBS Spacetime. Let's pull it up. There we go. Oh, the light cone.
We start with space-time. Well, a representation of it. We have 2 dimensions of space instead of 3 because we replace the vertical axis with time. At the bottom is the beginning of the universe, and time ticks forward, moving up. A planet forms 10,000 light years away from us. It moves through time, aging and evolving. At some point, an alien civilization on the planet starts sending radio waves moving at light speed through the universe. Earth also forms, and during one of their signals' 10,000-year journeys, we become a technological civilization and intercept the now ancient transmission. Because of this, we send a starship, your ship, on a mission to find our distant neighbors. And this is where our past light cone comes in. This cone defines all that we can see of the past universe, limited by the speed of light. The point at which that transmission was sent was long ago, but that moment is within our past light cone. However, the planet continues to move through time. Their civilization has now gone outside the light cone. But there's hope. We also have a future light.
That was all of Matt's message that I received. But what he was going on to say was that there is the past light cone and the future light cone. As I fly along the diagonal of our future light cone, the hope is to intercept this planet that sent us a message. But here's the rub. So much time has passed since that message was sent that by the time I reach this planet, who knows if the race that sent it is still there? Or for that matter, the planet. Either way, I have to head back home after, but Earth continues to move through time as well. And as it does, I'll move back towards it, hopefully to intercept. The future light cone represents the part of the universe that we could ever hope to travel to or communicate with. The boundary of the cone is the boundary for communication, or travel at the speed of light. We can never interact with anything outside that cone. It's important to remember that points both inside and outside the cone are events, not places. They're moments in both time and space. You can get to any point in space if you travel for long enough, ignoring the expanding universe, but there are moments in space that are unreachable, no matter how fast you travel. So by the time I reach my destination, who knows what will be there? Who knows if the civilization that sent that message will remain, since it took 10,000 years for their signal to reach us, and an additional 10,000 for me to reach them. I went out searching for what we thought was known, when we should always be searching for the unknown. And after I fulfill my mission, I fly back home, a place that I won't have known for 28 years from my perspective. On Earth, 20,000 years have passed. Think about what life was like 20,000 years ago as compared to the present. Think about what life must be like now. All the events, the people, the moments that have gone by in an instant. We think of the present and dream of the future, not really considering that what we do today could impact the next generations. When you look into this vastness, you think of all the possibilities. You wish that maybe 20 years earlier someone else would have done this journey, so we'd be even just the slightest bit further. We would have pushed just a tiny bit more to understand the incomprehensible. It's funny out here. I spent a lot of time thinking of early explorers, early pioneers. If you had told someone in the 19th century that they'd be able to get from one side of the United States to the other in 5 hours instead of 6 months, they'd think you were crazy, that no person could travel that quickly, that it couldn't be done. People would get on ships and set sail for months to get from one point on the planet to another, not knowing if they'd make it, not knowing what would be waiting for them on the other side, not knowing what would happen to those they left behind. We thought our ships were our speed limit until we pushed through that supposed limit and created something better. Limits. Limits. Just like we have a speed limit in space to how fast a message can travel, so did they. The ones they left not knowing if they had made it until months later, when a letter on a very similar journey would hopefully make its way back. I traveled to the unknown only to return to another unknown. like the explorers who pushed across the seas and cut through the wilderness on Earth, discovering what to them were new lands. We too must make the sacrifice to explore the universe, not knowing what will be on the other side of this ocean of stars, but with the hope that our journey will further our curiosity, further our humanity. We might be confined by the light cone. It might be a limit, but it won't stop me from trying. And, as always, thanks for watching. You're still here. That is fantastic news because I have two things to share with you. The first is that I made a video over at Sesame Street's Sesame Studios. It's all about space and astronauts and the moon. It is very cool, but it is meant for kids between the ages of 2 and 6. So if that is you, go check it out. Or if you're just curious to see what kind of video I would make for kids, well then maybe give it a look. There is a card here or a link at the top of the description. The second thing is that I would very much like to thank my friend Matthew O'Dowd for talking to us about light cones and traveling through space. He is a very smart gentleman and his channel, PBS Spacetime, is really mind-blowing. Link in the description to that as well. Okay, I'm gonna go. Farewell.